We will start standard deviation, which is considered to be one of the most difficult topics of the exam. Okay, so if I define standard deviation, it is basically a measure of the dispersion of a set of data from its mean. So what exactly is dispersion? That dispersion tells us how much our data is spread out. Basically, standard deviation tells us that how much our data is spread out, how much data is stretched. And if we consider, to get an idea about the standard deviation, if we consider a set, for example, we have a set A is equal to having elements x1, x2, x3 up to xn. And consider that the mean of this set is, the average of this set is x bar. So what exactly will be the standard deviation? Standard deviation will be the square root of sum of squared deviations from the mean divided by total number of elements in a set. And if you see, how can we write this? So on the numerator, we have sum of the square deviations from the mean. And for each element, we need to find deviation from the mean, and we need to take the square and add those. And the mean is x bar. The first element is x1, the square of that. The mean is x bar. The second element, x2, the square of that, up to the last element, which is xn, whole square, divided by total number of elements, which is n. So basically, there are two main components of standard deviation. One is the deviation part. One is the deviation part, and other is the total number of elements. Now let's see how this formula works. Then we will try to build up some intuition out of this formula. For example, just consider a very basic set. For example, we have a set having elements 1, 2, 3, 4, and 5. So what is the arithmetic mean of this set? That will be 3, because the set is evenly spaced. When the set is evenly spaced, the middle value is the average of that set. So let's see the deviation. First, see 1. 1 is how much below the mean? 2 deviations below the mean, plus 2. 2 is how much below? 2 is 1 value below. 3 is at the mean. 4 is 1, and the 5 is, it doesn't matter whether I consider this negative or this negative, because in actual we are taking the squares of each value, and the last is -2. So if you see the formula, now the formula will be 2 square plus 1 square plus 0 plus -1 square plus -2 square divided by total number of elements, which is 5. And this came out to be 10 by 5, which is under root 2, right? So this was just an idea about the formula. And to be honest, you won't be asked to directly find a standard deviation of some value. Just like in this scenario, we are given the 5 elements, and we're asked to find the standard deviation. We will never be asked in this way, right? But I was just about to give you an idea how standard deviation is asked. Okay. So here we were just seeing the formula. And in formula, there are two main components. One is deviation from mean, and the other one is total number of elements. Now, if I consider two sets, for example, One set A is 3, 4, 5, 6, and 7. And set B is 3, 4, 6, and 7. These are two separate sets. And what is the mean of these two sets? The mean of first set is 5. And the mean of other set is also 5. If you see the deviation of each element from the mean, we have 3, 4, 5, 6, 7, this set, and we have 3, 4, 6, and 7. In the first one, our mean is 5. So 3 is how much below 5? -2. 4 is how much below 5? -1. And 5 is at the, I'm writing this is deviation. 5 is at 0, 6 is 1 above, and 7 is 2 above. And if we see the other one, our mean is 5, 3 is -2 below, -2 means 2 below, 1 below, 6 is 1 above, and 7 is 2 above. And if we see the formula, in the formula on the upper side, we have sum of the square of each deviation, which is plus -2 square, plus -1 square, plus 1 square, plus 2 square, which is 2 into 2 square, plus 2 into 1 square, which is 2 into 4, plus 2, which is 10. In first scenario, our sum of square deviation is 10. In other scenario, this is also 10. This also came out to be 10. Now you can see we have two different sets, but the sum of square deviation is same. Now the only thing that will make the difference is the total number of elements. In first, we have total number of element 5, and in others, we have total number of element 4. Now, if you see the standard deviation formula, standard deviation is under root of sum of square deviation, which is 10 over 5. And in this case, this is 10 over 4. Now, which set has a greater standard deviation? Set B will have greater standard deviation because numerator of both are same, but denominator of set B is less. That's why standard deviation of set B is greater. So just keep in mind that the number of elements play a vital role in finding the standard deviation. And they, just like this scenario, the sum of square deviation could be same, but the only thing that will make the difference in that scenario will be the total number of elements. Now let's move further. At first, we just see the formula, and then we see what are two main components of the formula. Now let's see how can we visualize various scenarios. Visualization is very important when you are just comparing two different data sets. For example, let's see how can we visualize different scenarios. For example, in first case, we have two data sets having elements 1, 1, 1, and same data set P having element -1, 0, and 1. So if we see both of these on the number line, in the first set, number line, all of the elements are at 1, 1, 1, and 1. In the set B, we have this as -1, this is 0, and this is 1. Now you can clearly see that which data is great as is a greatest, have a greater stretch, greater dispersed from the center. Definitely set B, right? And at first, all of these are at the same point. And remember, standard deviation is 0 when all of the elements are same because there is no deviation from mean. In this scenario, standard deviation is 0. In this scenario, there is some standard deviation greater than 0. There is no need to find standard deviation. So everything getting my point? You are basically seeing how much your data is spread out. Greater the spread, greater will be the standard deviation, and lesser the spread, and lesser will be the standard deviation. This is first scenario. The second scenario is, for example, now we have two data sets, and we have 1, 2, 3, and B is 6, 7, and 8. Now, can anyone tell which data set has greater standard deviation?
Both have equal.
Yes, both are equal. Just see the number line. This is 1, this is 2, this is 3, this is 6, this is 7, this is 8. They are equally spaced. In this scenario, 2 is the average. In this scenario, 7 is the average. The smaller one is 1 deviation below. This is 1 deviation above. This is 1 deviation below, and this is 1 deviation above, right? This is a simple case in which standard deviation is same. You can also think of this, which we will discuss a bit later. Then when you're adding a same element in each of the set, the standard deviation remains same. And A could become B if you add 5 in all of these. Right? You can also think this way. Okay, now let's see the third scenario. Third scenario is like, for example, set A is 1, 2, and 3, and set B is 0, 1, 2, 3, and 4. Now, can anyone tell which set has greater standard deviation? Anyone?
A.
Okay. Anyone else?
B.
Yes, B. The reason is, if we just consider a 1, 2, 3 for time being in both of the sets, this is 1, 2, and 3. And this is also 1, 2, and 3, right? Right now, standard deviation is same, but now you're adding 2 elements, 0 and 4, and those are very much far away from the mean, which is 2. In short, you are just stretching your data a bit far above from the mean, right? This is actually the concept of the standard deviation. Greater the stretch from the mean, greater will be the standard deviation. And in the same set, if you add any element exactly equal to the mean, for example, earlier we have both 1, 2, 3, 1, 2, 3. Now, if you add, this is 1, 2, and 3. Now, if you add another 2 in the data, now the data will be a bit shrink at the center, a bit concentrated at the center. That's why in this scenario, the standard deviation will decrease. Just remember this, if you want to increase the standard deviation, try to incorporate some values that are a bit further from the mean. And if you want to decrease the standard deviation, just add any value which is exactly equal to the mean or very close to the mean. So everyone is getting my point? And this thing is highly tested, that how could you minimize the standard deviation? That is only possible if you put any value that is exactly equal to the mean or somewhere close to the mean. And if you want to increase the standard deviation, just take any value that is at a greater distance from the mean, because in that scenario, your data will be more spread out. Okay. Now, for example, if I say that the set A is 3, 4, 5, and data set B is 3, 3, 4, 5, and 5. Which set has a greater standard deviation? Be quick. Data set A or data set B?
A.
Wrong. This is what we exactly discussed right now. If you see, both of these have 3, 4, and 5, 3, 4, and 5, 3, 4, and 5, 3, 4, and 5. The mean in both is 4, right? Now, if you just, in the second set, you add one more 3 and one more 5. Those are very much far away from the center. That's why the standard deviation will increase. You can also use the formula and check whether standard deviation increase or decrease, and you will come to know that standard deviation actually increase. Now let's see some basic properties. Our basic rules, you can say these are basic rules. First one is, if you add or subtract same element, a same number from each of the element, from each of the element or number of the set, there will be no change, there will be no effect or standard deviation. Right, this is the first rule. If you add or subtract same element from each of the number of the data set, the standard deviation will not change. For example, if you have data set A, 1, 2, and 3, and if you add 2 in, not 2, 4 in all of the set. For example, if you add 4 in all of the elements, you knew the data set will be 5, 6, and 7. The standard deviation of both will be exactly same. There will no effect on the standard deviation, but remember, you are adding same number in each of the number of the data set. And if you want to quickly check whether this is correct or not, in the first scenario, what is the mean? Mean is 2. So what is the deviations? Deviation for 1 is -1, deviation for 2 is 0, and deviation for 3 is +1. So if you see the formula, that will be -1 square plus 0 square plus 1 square divided by 2, which is 1 plus 1, not 2, divided by 3, which is under root 2 by 3, right? Now, if you see the second one, it will be again, mean is equal to 6, and the deviation for 5 from mean is -1, and 7 is +1, and for 6 this is 0. So standard deviation is formula is again -1 square plus 1 square divided by 3, which is under root 2 by 3. Right? So in both scenarios, standard deviation is same. So first thing is, if you're adding same number in each of the number of a data set, there will no effect on the standard deviation. Now the next is for the subtraction part. If you subtract same element from each of the same number from each of the number of data set, there will be no effect on the standard deviation. If you take the example 1, 2, and 3, if you subtract -3 from each of the number, the new data set will be -2, -1, and 0. Again, mean is 2. Deviation of each element from mean is -1, 0, and 1. In this scenario, again, mean is -1. Deviation of each element is -1, 0, and 1. So deviation in both are same, and total number of elements are same. So your standard deviation will also remain same, right? And third one is about the multiplication. If you multiply with same number to each of the number of a data set, there will be effect on the standard deviation, and standard deviation will be scaled by that number. What that means? For example, if we have A is equal to 1, 2, and 3, and if we multiply each of the value from 5, multiply by 5, multiply by 5, multiply by 5, your new data set is 5, 10, and 15. So what is the standard deviation? First case, mean is 2. Deviations are -1, 0, and +1. Standard deviation is again sum of the deviations. Scarce deviation 1 plus 0 plus 1 divided by 3, which is under root 2 by 3. This is 3. Now see that this scenario, mean is equal to 10. Now see the deviation. 5 is -5 below, this is at 0, and 15 is +5. So just use the formula. Standard deviation will be -5 square, which is 25, plus 0 plus 25 divided by 3, which is 50 by 3, which is 5 under root 2 by 3. This is same as the above standard deviation, but this value is scaled by 5, or this value increased by 5 times, by 4 times, which will become 5, right? Okay, The other thing is, the last thing is about the division. And this will exactly same effect. And for example, if we see, if we have 2, 4, and 6, and if we divide all of data element by 2, new data set will be 1, 2, and 3. And we have discussed this earlier. This standard deviation is under root 2 by 3. And for this, mean is 4. Deviations are -2, 0, and +2. So standard deviation will be -2 square plus 0 square plus 2 square divided by 3, which is 8 by 3, which came out to be 2 under root 2 by 3. So in actual, our standard deviation is 2 under root square root 2 by 3. But by dividing each element by 2, our standard deviation become exactly half, which is under root 2 by 3. So the takeaway from this is, if you are adding or subtracting same number from each of the element, there will no effect on standard deviation. And the next point is, if you are multiplying or dividing same element with each of the number of the set, the standard deviation will be scaled by that factor. Either increase or decrease, depend upon whether that is an integer or whether that is a fraction or whatever the value is. Okay, there's one more thing, very important thing, and no one asked me that thing. For example, if we have a set having values 2, 4, and 6, and if I multiply all of the values by 2, this will become 4, 8, and 12 if we multiply by 2. But if I multiply by -2, this will become -4, -8, and -12. Will there be any change in standard deviation of these two sets? This one and this one? No, because standard deviation actually measures the deviations from mean. And if you multiply by 2 or -2, you are increasing each value 2 times. Doesn't matter, the sign doesn't matter, because we are taking the squares, and in last we are taking the square root. So negative sign doesn't matter here. And remember, standard deviation is actually a distance, and this can't be negative. We can't have negative standard deviation in any case. This must be positive. This must be positive, and this can be 0 in only one scenario, when all of the elements are same. In that scenario, all of the elements are equal to the mean, and there is no deviation from mean, so standard deviation is 0, right? Now the next thing is very important thing, and this is highly tested and a very tricky thing. Anyone of you know about the variance? How variance is related to the standard deviation? Actually, standard deviation is equal to the square root of variance. Or you can say that variance is equal to square of standard deviation as sum of square deviations from mean divided by total values. Now, again, you won't be asked straightforward with values to find the variance of a data set. But let me give you a scenario, and that is pretty much common scenario. That's how the variance could be asked. For example, if we have two data sets, data set A, data set B. And we are provided total numbers, mean, and arithmetic mean, and variance. And the statement is just like the total number of values in A is half of the total number of values in B. So you can write this as, in data set A, we have n values. In data set B, we have 2n values. And then let's divide these first. And the arithmetic mean is same in both of the scenarios. Let's call that M. And the variance is different. For example, consider values like 26 and 59. So I will repeat the part that we have two data sets, A and B, and total number of values in data set B is twice the number of values in data set A, and the arithmetic mean is same in both of the data sets, and variance of both data sets are 26 and 59. Now, if we combine two data sets, what will be their new variance? The question is, by combining data sets, what will be their new variance? Now, can anyone find this? Anyone? We are given two data sets. Total number of element data set B is twice the total number of element data set A, and the arithmetic mean is same in both scenarios, but the variance in first data set A is 26 and data set B is 59. And the question is, if we combine both of data set A and B, what will be the new variance? Okay, now just think of this. First of all, our variance is equal to sum of squared deviations divided by total number. Right. Now let's see the first data set A. We have total numbers is equal to n, right? So let's consider total elements. For example, we have x1, x2, x3 up to xn, right? So we have total n elements, x1, x2, x3 to xn, and mean is m, right? And we are given that the variance is equal to how much? That was 26. Now, if we use this formula, variance 26 is equal to sum of deviations. And if mean is m, first deviation from mean is x1, square of this, plus m minus x1, x2 square, plus up to m minus x, and the last one square divided by total number of elements are n. So this m minus x1 square plus m minus x2 square plus up to m minus xn square is equal to 26n, right? For time being, just consider this, right? Everything is understood till now, right? I'm just playing with the formula. We know the total number, we know the mean, we know the variance, and I just consider the values are x1, x2, x3 to xn. This is for the data set A. Now let's see the data set B. If you see the data set B, in the data set, total number of elements are twice that are in data set A, which is n2n. And now if I consider the number of elements y1, y2, y3, up to y2n, I'm considering elements of this data set. And mean is equal to m. and variance is equal to 59. Again, if I use the formula, variance, which is 59, is equal to sum of square deviations, which is m minus y1 square plus m minus y2 square up to plus m minus y21 square divided by total number of element, which is 2n. So this will become m minus y1 square plus m minus y2 square up to m minus y2n whole square is equal to, what is 59 into 2? That is 118. And right now we have these two equations. First of all, if data set A has mean and data set B and same mean, so if we combine those, the data set, new data set will have same mean, right? You all agree on this point? If you are combining two data set with same mean, the new data set will also have a same mean, right? So if we combine data set A and data set B, and for example, if I call that data set C, which is combination of data set A and B, right? Now the mean is M, number of elements is n plus 2n, which is 3n, and we need to find the variance. Okay, now if you remember the formula of the variance, variance is equal to sum of square deviations divided by total number. And yeah, we have already combined the total both data sets, and that's why now the number of elements are x1, x2 up to xn, then y1, y2 up to y2n. So mean is same, m minus x1 whole square plus m minus x2 whole square plus up to m minus xn whole square plus m minus y1 whole square plus m minus y2 whole square up to m minus y2n whole square divided by 2n plus n, which is 3n. And now if you see this closely, we already know both of these values. This is from the first data set when we use the formula, and this is from the second data set which we use the formula. In the first data set, this value came out to be how much? This value came out to be 26, and this value. This is 26n, and this value came out to be 118n divided by 3n. What will be this value? This will be 144n divided by 3n, which is equal to 48. So I even got the point. What actually happened in this question? So takeaway from this question is, when you're combining two data sets with same mean and different variance, when you combine those to find the variance of the combined data set will be just the weighted average of those two variants. So if we already discussed the weighted average concept, data set A, number of elements, and variance is n, and variance is 26, and data set B has 2n element and variance is how much? 59. And now if you want to find a combined variance, that will be just the weighted average of these two. First one, I'm using a scale method which we already discussed in the last lecture. This is 26, this is 59, and the ratio of these will be n over 2, 1 is 1:2. So this will be 1, this will be 2, x. So this will be 3x, and 59 minus 26 is equal to how much? that is equal to 33. And this way x came out to be 11. We know the x, so this will be 26 plus 2 into 11, which is 44. Not 44, 48. So I even got the point, because this concept is tested again and again. So try to understand this. Same question could be asked in which the number of element could vary. In this question, we are given that is twice. They could be 4 times, 5 times, whatever the values. But the main thing is the mean is same in both cases. So when you combine this, the overall mean will remain same. So in this scenario, you can use the weighted average and find this thing, which will, in short, is the combined variance of the whole scenario. And there is one more way in which the standard deviation could be asked. That is more probably in the word problems form. You will be provided with the whole scenario, and we will see one question when we start solving. In that question, we are provided with a sort of equation like y is equal to 2 by 3x plus 22. And in that scenario, we are provided that in a class, we have some number of students, and their actual scores deviation is x. But teacher want to adjust their score using this formula, and we are asked to find, if we know the old standard deviation x, so what will be the new standard deviation of y? If I say that old standard deviation for x is, for example, 30. So what will be the new standard deviation of the whole class? How can you find this? What will be that value? Okay, someone is saying 40. How much? 42. Okay, anyone else? This is not 42. I told you some properties for standard deviation earlier, that if you multiply or divide, the standard deviation will change. But if you add or subtract, there is no effect on standard deviation. Likewise, in this scenario, this thing is multiplied with old deviation, but this thing is added. There will no effect of 22 on the actual standard deviation. The new standard deviation will be just y is equal to 2 by 3x, which is 2 by 3 into 30, which is 2 into 10, which is 22. Which is 20, right? So whenever you're asked to find the standard deviation in the word problems form, right? Just remember, standard deviation will only change when you are multiplying or dividing. You're just adding or subtracting, there will be no effect on the standard deviation. Let's quickly wrap up that how could the standard deviation could be asked in exam. Just see common scenarios. First scenario is you could directly be tested by the concept which we discussed earlier about the addition or subtraction or multiplying or dividing same number with each same number to each of the element of the set. Right. This is first concept. If you are adding or subtracting same number, or you are multiplying dividing same number with each of the element of the set. So let's remember, the only effect will be when you are multiplying or dividing. That value will be scaled by that factor. When you're adding or subtracting, there will be no effect on the standard deviation. This was actually the first concept which is tested. The second thing which is usually tested in question form, in which you're asked to compare some data sets. And their length, their number of elements could be same and could be different. And one more thing, which I forgot to tell you earlier, that if you're having two data sets having same number of elements, just like this, 3, 4, and 6. In such scenario, you can also see the range. Greater the range, greater will be the standard deviation. In this, which is 2, 3 minus 1, 2. In this, 6, 3 into 3. 6 minus 3, which is 3. So when you are having a smaller set and you already know the total number of elements, and in both sets, these are same. So you can use the range concept, greater the range, greater the standard deviation. This is a second type of question type in which you are comparing the data sets and their lengths could be same, the number of element could be same and could be different. The third type is you're usually asked that how can you, you are provided with 5, 6 values of the any number, and you're asked which will you incorporate in the data set, and standard deviation will decrease. So just remember, standard deviation will actually decrease when you add element exactly equal to the mean. Right? So remember, standard deviation will be decreased or minimized when you add element exactly equal to the mean. These are usually third type of question you ask, and fourth type, which we discussed earlier, is about the variance and that concept, that how we combine, how we find the combined variance. Okay, and the fifth one was in the word problem form. And the last thing, which just came in one of the student exam, and for that you need to think yourself. I'm just giving you idea about that. The thing is, you are, for example, provided with this data set 1, 2, 3, 4, 5, and 6. And if I say that and its standard deviation is x, for example, x, we don't know, just consider this x. If I say that if I add 5 in one of the element of data set A, the new standard deviation is, for example, y. And now if I compare, first you repeat the question that, for example, if a data set A having 6 elements, 1 to 6, and for example, the standard deviation is x, consider as x. And we are asked that if I add 5 in any one of the element, that could be added in any of the element, the new standard deviation is y. So now if I ask to compare this is quantity A and this is quantity B, the standard deviation for first one is quantity A is x plus 3, and this is y. This is old standard deviation plus 3, and this is new standard deviation, which is y. So this is and this usually this came in the hard section. So when just use the online calculator from the standard deviation and try to think, if this is your data set, and if you're adding, let's suppose 5 here, then change, then 5 here, then 5 here, then 5 here separately, and try to see what is a change in the standard deviation, and try to think a bit logically about the standard deviation. So these are a bit 5 or 6 or 7 ideas that how could the standard deviation could be asked.